Okay, good day, sir. So I will be presenting about the SafeBoard project simulation. So first of all, we need to connect the pins to the breadboard rail to set up. So the 3.3 volt pin will be connected to the red rail. The 5 volt pin will be connected to the another red rail, and the ground pin will be connected to the ground rail. So after that, let's look into the keypad. So the R1 to R4 pin will be connected to the digital pins to their respective pins, while the C1 to C3 pin will be connected to the analog pins. So after that, we will look into the LCD display. So this is connected to the I2C, so we don't need to use all these 12 pins. The 4 pins will be sufficient. So the ground pin will be connected to the ground rail. The VCC pin will be connected to the positive rail. The SDA pin will be connected to the A4 analog pin, while the SCL pin will be connected to the A5 pin. So after that, for the RFID, the 3.3 volt pin will be connected to the red rail, the 3.3 volt red rail, and same for the RSD pin, it will be connected to the 3.3 volt red rail. As for the GND pin, it will be connected to the ground rail. And for the IRQ, which is for the interrupt, we don't use that, so we leave it blank to save some pin storage. So after that, the MISO pin will be connected to the digital pin 12. For the MOSI pin, it will be connected to the digital pin 11. And for the SCK pin, it will be connected to the digital pin 13. While for the SDA pin, it will be connected to the digital pin 10. So after that, we can see that there's a power supply here because the battery pack isn't available in this simulation. So we use this power supply as a replacement. So the positive pin will need to be connected to the row here. And for the negative pin, which is ground, we should connect it to the ground rail. So this battery pack or power supply is for the servo motor, which needs a higher voltage for it to work. So for the ground, it will be connected to the ground rail as usual, but for the VCC pin, it will be connected to the row same as the power supply. While for the PWM pin, it will be connected to the digital pin 6. So after that, let's look into the buzzer. The positive pin will be connected to the digital pin 7, while the negative pin will be connected to the ground rail. So next, the LED. The cathode will be first connected to the to a resistor, 220 ohm resistor, followed by connecting it to the ground rail. While the anode will be connected to the digital pin 2. So for the last one, the ultrasonic sensor, the VCC pin will be connected to the positive rail, while the trig pin will be connected to the digital pin 8. For the echo pin, it will be connected to the analog pin 3. And for the last one, the GND pin will be obviously connected to the ground pin, to the ground rail. Okay, so without further ado, let's look into the code. So as we can see, the first one here is the libraries. We need to include all the necessary libraries from our sensors and components for them to work properly. So after that, we can see that the EEPROM is false, is set to false, because in simulation, it is not working, so we set to false, or else bugs will appear. While in the real-life simulation, we can enable it to use the EEPROM function. So after that, it will be the pin definitions. So all the pins are defined based on what the components are used. And after that, we will need to set up the keypad. based on the rows and columns with all the pins, like another pin 0, another pin 1, another pin 2 for the columns, and the rows, the pin, these are pin 3, 4, 5, and 9. So we set up them here. So after that, we need to declare the global variables, and after that, we have to enter the setup mode. So we begin the serial monitor, and we enable the LCD, and there's a sound startup. So after that, we check for the EEPROM function. So if there's a previous memory loaded, it will load the RFID UID and the pre-save pin. If the EEPROM doesn't have any data, it will load the default pin and it will enter the setup mode. So after that, let's look into the okay, so before that, we can see that there's this low gain fix. So let me explain why I need to use this code. It's because like the RFID sensor that I use is an OEM, and in the default state it will generate a lot of static electrical noise which causes a malfunction. So I need to apply this low gain fix which sets it to 18 decibels to allow it to work. Okay, so after that, the next function will be the check admin card function. It checks for the admin card. If there's no admin card, it will enter setup mode. And if there's an admin card, it will directly enter the system lock mode. So after that, which is the calibration feature, it will allow the ultrasonic sensor to calibrate itself. So when the lid is closed, it can detect it properly. So after that, we can enter the main loop state, which loops the code. The handle LED animation is obviously handles the LED animations. So the switch case code will depend on which state the system is in. Like lock, it will run the code state lock, and for the await pin state, it will run the code state await pin, and vice versa. So let's get into the LED logic, the handle LED animation. So if the system state is the alarm state, the LED will flash quickly. If the system state is unlocked but the lid is closed, it will enter the breathing state. So if the system state is locked and the system state is awaiting the pin, the LED will enter a blink state. So this is the state functions that we talked about just now. The state lock function, it will listen for the RFID card, and after the RFID card is scanned and it is correct, the LCD will print the card OK, and they will get to enter the pin. So which is the state await pin function, and the check for temper function is always here to check for any unauthorized access. So after that, let's talk about the state await pin. So if it is not from recovering from alarm, it will check for temper. Yeah, and if the state is alarming state, it will return to the alarm state and disable the await pin feature. So after that, if the user did not enter the bin for a long time, for 20,000 milliscans, it will say timeout, and it will go back to the lock state. So after that, if we need to get the key first from the keypad. So after that, after the user enter the pin, they need to press this hashtag button, the hashtag key, to submit their details. So if the input password is same as the correct password, it will unlock the door, or else it will lock the door. The door will still be locked, and it will say wrong pin on the LCD. So after that, for the state unlock, there will be a feature there will be three features, namely the recalibrate feature. So to enter the recalibrate feature function, the user needs to press this asterisk key, and it will enter the recalibrate state. And as for the change pin feature, the user will need to enter the hashtag key, and it will enter the change pin state. After that, if the user wants to change the card, they can press the 0 key, and it will enter the change admin card state. So if the user forced to close the lid but the lid is open, it will display an error via a sound, and the LCD will print lid seems open to notify the users. So this is for the auto lock function. So if the lid is closed but the user didn't lock the door manually via the RFID card, the system will lock itself in 15 seconds. Okay, so this is the sound function. The sound will be played based on what the current situation is with the different tone. Okay, so without further ado, let's get into the simulation. Okay, as we can see, the system will enter the setup mode because this is our first time setting up the system. So we need to present our RFID card first, and we say ID save, and the system will now enter the lock state. So to unlock, we need to first present our RFID card, and we say card OK. So we need to enter our pin, which is 1234, the default one. And we press the hashtag, and the lid is unlocked, so it will display welcome. So let me explain the features first. So the first feature, the recalibrate feature, we need to press this asterisk key and recalibrate based on the ultrasonic distance. So after that, for the 0 key, we can change the admin card. Present our card, and the card will be updated. So for the hashtag key, we will enter the change pin mode. We need to enter our old pin, and we can set our new pin, and the pin will be changed. So this is actually the auto lock function. If we close the lid but we don't lock the door via RFID card, the lid will close itself in 15 seconds. So the door is closed. Okay, so let's simulate a alarm feature. So let's say we change the distance to higher. So the temper alarm will activate, and the LED will flash quickly. The buzzer will also sound, but in this simulation the buzzer don't sound, but in real life it will sound. So to disable the alarm or to silence the alarm, we have to present our RFID card first. Yeah, the system is lag a bit. So okay, after that we can enter our pin. No, actually we changed our pin just now, right? So we enter the new pin. 1, 2, 3. Okay, so access is granted, and we can use the save box as usual. So that's it for the simulation. Thank you.